graphing some quadratic and other equations. Basically, any graphs that aren't straight lines. So we're going to have a look at some different curves. And you need to know and recognize these different shapes. So let's have a look at some of them. A simple graph that we might look at to start with might be something like x squared plus 3. Now, you're either going to be allowed to use a calculator to do this, so we can either have our calculator and we've got a way of doing that in the calculator, or we may have to try and do this without a calculator. So we're going to do it without the calculator first. So we're going to have a look at the points here, x, and we'll look at y, and here we're going to do it from -3, -2, -1, and let's go up to 3. So we're going to look at x squared and add 3 on. So this is going to be -3 times -3 is +9, plus 3 gives me 12. And then we've got -2 times -2 is +4, plus 3 is 7. -1 times -1 is 1, plus 3 gives me 4. Nothing is going to just give me, nothing plus 3 is going to give me 3. And then this side is going to be the same as the other one. It's going to be a symmetrical graph. Just to give you an example, 3 3s are 9, plus 3 gives us 12. So there's our symmetrical graph. And what we want to do now is to use a ruler to try and draw these. And typically I've lost my ruler, so I'm just going to use this other shape ruler for a moment. And what I want to do is I want to get a good 12 on here, and we're going to go from, if I just zoom out for you, you can see that we're going to go, if I'm going to go here, 12, 11, we're going to go around here like this. Now, sometimes you'll be asked to draw these things with either a sort of a standard scale where they're the same. Sometimes you might be asked to have a larger scale on one side. So what we could do is we could spread that out, but it will ruin the shape of the graph, what we're having a look at the moment. So we're going to leave this here. I'm going to pull this down just a little bit so you can see the results. Right, at -3 we're up at 12. At -2 we've got 7. At -1 we've got 4. At 0 we've got 3. And then this shape is basically made. Now comes the hard bit. What we've got to try and do is we've got to try and draw a curve freehand that's going to go through each of these different points. And it's certainly not easy to do this. I don't think I quite got that one right. Hasn't got myself a nice curve going there. I find it easier to draw it that way, not so easy that way, and so what I would usually do here is I could turn my piece of paper around just so that I can draw what I'm trying to do. So there is our graph of x squared plus 3. Now let's have a look at this sort of graph and see what happens. Well, if we make a mistake on these things, you might find that we've got a point that's going to be perhaps down here, and it's then obvious that it's not right. You know, that figure could be up there, and then we could think, oh, it's not right shape. So if we've got mistakes, usually they're fairly easy to spot, and it's always a good idea to try and label this graph here. I can label that line as y, and I can label this line as x, and there is our graph. Now if I'd just done a graph of x squared, let's have a look at what that might look like. So I'm just going to draw the values of x squared in. This is going to give us 9, 4, 1, 0. I didn't do that right. 1, 4, and 9. Right, let's have a look at what this graph looks like. So it's going to go through 0, and this time I am going to just zoom out a little bit. Let's draw this line as best as I can. Didn't quite get that one right, and then let's just carry on turning this round, and here I've got that graph. Let's look at both of those graphs together, and you can see that these two graphs are in fact exactly the same shape. The difference is that this one is y equals x squared, and this is x squared plus 3, and you can see the plus 3 has just taken that graph and moved it up. Now we may want to try and do this by changing some of our values, and we can use our calculator to do this. So what I could do is simply switch the calculator on, and we can put it in the right mode, and here this one has got a table to help us do this. I'm going to show it to you on this one, menu, and it's got a table, and we can put in our particular function, and this is going to be x squared plus 3. I haven't got a second graph. I'm going to start here at -3. I'm going to end at +3, and we're going to go up in ones. And here we can see we've got our numbers, and they correspond to our 12, 7, 4, 3 that we see on our paper when we actually made this. So we can do that. Now, as well as that, we can in fact use a different calculator, and I've got here a different calculator. This is a graphical calculator, and if I select here a graph, and I'm almost certainly got some graphs in here, yeah, I've got some in here, so let me just delete these. And let's go and put in our new graph, and here it's going to be x squared plus 3. I press X, and then I can draw the graph. If it doesn't make any sense, what I can do is zoom, and I'll set here to auto, and we can see here is the graph. And I can move it down a little bit, and you can see this scale here, the Y scale is very different to the X scale, so this one will need a little bit of work on it to modify this graph so that I can see various things about it, and I can set my lines and windows, and I can zoom in, and I can do all sorts of bits and pieces on this. This is the sort of calculator where you need to learn very much so what it can do, and it's one of the few we need to seriously read the instructions before you can use it. So let's have a look at, rather than this graph, let's have a look at some more graphs and see what we can do with those. So let's just move that out of the way, and let's try another graph. So rather than having a look at that one, let's have a look at, there's a whole family of these where I could look at x squared plus 1 plus 2 plus 3, and the idea is they will just sort of the same shape, but it's going to move up and down, especially down if I did something like -6. So they're all going to be exactly the same shape. But what happens if we look at something like x squared plus x? So let's have a look at that little graph. So I've got my table, I've got x, and we'll do from -3 again to +3. So I've got my x, we can work out what my x squared is, and then I can work out what my y value is. That's going to be x squared plus x. So here, -3 times -3 is 9, 2 2's are 4, -2 times -2 is also 4, 1 0 1 4 9, and let's now add on this value. So we've got 9 minus 3 is 6, 4 minus 2 is 2, 1 minus 1 is 0, nothing minus nothing is nothing, and again we've got, I was doing minus x, aren't I? I'll look at minus x, why not? 1 minus 2, so it's going to be 4 minus 2 is 2, and 6. Again, we can see that this graph is going to be basically a symmetrical graph. Let's have a look and see what it's going to look like. So let's put on our label 6, 5, 4, 3, 2, 1, and 0. So that gives us our graph. Let's put in our first value then. -3, it's going to give us 6. At -2, it's going to give us 2. And all the others are going to be at 0. And then we've got 2. And we've got at 3. We've got 6. So this gives us an interesting shape graph. going to rotate this right round so I can draw a better line. And there we have our graph. We could have got the values from our calculator, and if I just cancel that and put in my new one, which was x squared here, and I did minus x, so let's do the same, minus x, again from 3 to 3, and I've got my values, which I've got wrong because I've jumped one, haven't I? So 12, 6, 2, 0, and carrying on down. So if we look at that on a graphical calculator, let's just cancel that, let's go back up to this one, and we'll go along and we'll edit this one as well. And it's because I've changed my mind halfway through a graph and I made a mistake. So at least I can show you what it will look like. And there's our graph. And it's just a more spread out sort of graph. So what would happen if we looked at a different type of graph? So let's now shove in a value to see what we can do. Let's go for a graph of 2x squared. So I'm going to choose my value of x, which is going to be again minus 3, minus 2, 1, 0, 1, 2 and 3, and I can work out what x squared is, and then we can double it. Let's do this one on the calculator. I'll make less mistakes that way. Let's get this one out of the way, and I cancel this. Let's put in my graph. In this case it's going to be of 2x squared, and there isn't going to be anything else, so we can delete that, and no other graph, and there's our values this time. And you can see that we've got a whopping great scale: 18, 8, 2, 0, and on the other side it's got those same values. Had we tried to have calculated those, it was easy enough. 1 squared is 1, 1 times 2 is 2, 2 squared is 4, 2 fours are 8, 3 squared is 9, 2 nines are 18. And you can see that it's sometimes just as easy to do it this way. So what's this graph doing for us? Well, I'm also going to put in the graph of x squared, and that was 9, 4, 1, 0, 1, 4 and 9. So let's see if we can draw this graph. Now, to get this graph going, then we've got to make this quite big. So what I'm going to do is I'm going to cheat a lot. And what I'm going to do is I'm going to say that I don't have enough room on here to probably get in the 18. I don't know whether I had. Yeah, I could have just about done that. Let's do it properly, shall we? I've managed to lose my ruler. Right, so I've drawn a whopping great big line here. And let's hope we can get this on. There we are. We can easily get it on here. So our values, then let's put them in at -3. I've got 18. In fact, +3, I've got 18. I'm going to draw it this odd way because I can move the screen down. And then I've got 8 as my next one. And then I've got all the way down here. 1, we've got 2, and there. As you can see, it's a whopping great big graph here. And I'm turning it round just so I can make it easier for me to try and draw it. And I didn't draw it brilliantly. Let's put on this same graph the other one. So here we've got a different set of values. 9, 4 and 1. So I've got at 3, I've got 9, at 2, I've got 4 and 1. And if we draw this graph in, not drawn particularly well, we can get an idea of something happening. What we've got this is x squared, this is 2x squared, it's getting tighter. If I did 3x squared, it's going to be even tighter. 4x squared, even tighter still. And if we go out and I do the graph of a half x squared, then it's going to be wider still. Let's try that one. And what I'm going to do here is I'm going to try the family of these graphs, and I've got, first of all, let's just do this one, which is going to be, let's change my mind. I'm going to do 4x squared. On my next graph, I'm going to do 3x squared. on the next one, I'm going to do 2x squared. On my next one, I'm going to do just simply x squared. And finally, on my last one, I'm going to do a half, which I'm just going to write in as 0.5 x squared, just to make my life a bit easier. And if we now draw these graphs, we can see that we've got a family shape of these graphs. 4x squared, 3x squared, 2x squared, x squared, and coming down eventually to a half. And you can see there are a family of graphs. Now, let's have a look and see if we can draw some other types of graphs. And as well as getting x squared graphs, we can get x cubed graphs. If you're asked to draw an x cubed graph, then they will probably give you again a range of values to do this from, and let's just try a slightly larger range of, no, we won't, we'll just do that. -3, -2, 1, 0, 1, 2, 3. We'll just try that. Right, so let's do x cubed. So 3 3s are 9, but 9 3s are -27. So -3 times -3 gives me -9. It gives me +9. +9 times -3 gives me -27. 2 here. -2 times -2 gives me 4. But 4 times -2 is -8. X cubed here of this one, -1 times -1 is 1. Times -1 gives me -1. Naught's going to be naught. And then this is going to be the same shape, but it's going to go the other way. Now they're whopping great numbers to do. So what I'm going to do is I'm going to plot this one on the graphical calculator. And so what I need to do is, let's go back and we'll go in here. And I really want to get rid of all of these, so I'm going to have to go up and delete them all. Here we go. Delete format, yes. What I want is a nice way of actually doing all of these in one go, but I don't know how to do that. No doubt somebody will kindly tell me. Right, let's go back, and I'm just going to draw a graph of x cubed. On this calculator we don't have a cube function. We do have, however, to the power of, and I can put in my 3. And if I draw this graph, we can see that in fact it's this sort of shape. And there it is from about 27 to -27 to +27. And we can see we get this interesting shape of this graph. So that's an x cubed graph. One of the other ones you'll get is one of these called a reciprocal graph, 1 over x. let's have a look at that one. If it's going to be x here again, and we're going to do 1 over x, so let's put our values in. Minus 3, minus 2, 1, 0, 1, 2 and 3. Now if I start doing these, then we'll cheat and we'll use the calculator to try and help us. If you got this in an exam, they would let you use a calculator almost certainly to do this one. So we're on my simple calculator, and I'm just going to, hopefully, I was hoping that was going to take that out, it did, here we go. So I've got 1 over x, and we get an interesting thing happen. It seems to make an error here. It can't seem to cope, and we get some interesting numbers. Well, let's draw this one out on the calculator and we can see what this one will do. So if I exit this and let's delete that one, this is going to be the graph of 1 over x. And something really weird happens. We get this sort of shape. And when we did this with 0, we got this error. And we get an error here because it can't seem to plot this graph here, because it simply doesn't go there. So we've got a series of graphs that we've drawn, and we need various ones that we need to sort of remember. So let me just draw in a few graphs for you fairly quickly and have a look at these. So this is the graph of x squared. But if I did instead minus x squared, then this graph would go the other way up. We've looked at a few graphs here. We've looked at ones like x squared, and then we can look at things like 2x squared. If I come out here, then we can go out, and that would be a half x squared, making that line going along there. We could have other graphs. I'm reminded I've got a ruler, I could actually use it here. But if I've got here a graph of, this is x squared, then the same graph here might be x squared plus 2 moving up. And it might be here, this would be x squared minus 2. You can see it's moving down. here is our graph of x cubed, but it's got a relative, and this graph is going to be the graph of minus x cubed, going the other way. You need to know all of these graphs and just be able to sketch them as I'm doing. We've got another graph. This was this one over x graph, the so-called reciprocal graph. So we can get some other interesting factors. And if I start changing this number here from 1 to 2 to 3, let's just go and do that on the graphical calculator. On this graphical calculator then, if I just exit that, that's 1 over x. Let's just do 2 over x, just so you've got a comparison here. That one's going to, the 1 over x is going to be in blue, the 2 over x is going to be in red. And you can see that basically, if I just zoom in, that it's getting less. And if I do another one of these, let's do something like 7 over x, you can see it's getting, if you like, shallower. So on here we can get the graphs going shallower as we look at this one, which is perhaps 2 over x. We could come up with another interesting one, and that is what would happen if I did minus 1 over x, and that gives us a graph shape the same as the other one, but this time they are going in the opposite corners. Now this line here is approaching 0, but it will never reach it. And that's given the name of an asymptote. So this gives us a whole series of different types of graphs we can look at. We can even get clever and put some graphs together. So let me just be keen. So it's got those deleted. Let's go up here and let's do a graph of x cubed. I don't want a plus there. Plus x squared. So we've got two graphs now joined together, and it doesn't quite make the one that you may expect, but we've got it sort of wider here. Let's go and see what would happen if I now made the graph perhaps and change its shape slightly. Let's do that, and I'll just show you very quickly what I mean here. So let's go into this graph here, and I'm just going to delete it and start again. I'm just going to do here x cubed, and let's now do the graph of 2 x cubed. Let's see what you expect with this. And we can see that they are going to get narrower. Is that what you expected? If I made this 0.5 x cubed, then I would expect this one to be a wider graph. Let's see if the green one is. So we can change the shape of these in the same way as the x squared worked, and if we put them together we can get some other interesting shapes as we play with them. So there are a whole series of different graphs. There are 3 more that I just want to show you because you might meet these. So if I just again delete these graphs, just so we've got an empty thing to have a look at, I've got another graph which is y. I'll write it for you I think first, and this is y equals some number, I'll call it n, to the power of x. We're going to make that 2. We'll try and see what happens. So this is going to be 2 to the power of x. Now it'll make life more interesting if we try another one, so let's just try 3 to the power of x. And let's look at these two, the blue and the red one, 2x and 3x. And they're graphs that go up and move on up, but interestingly down at this point here you can see it's drawing an enormous scale up as it goes rockets up. But what we get is they always go through the point 1. So if I were to draw this graph, there's my 0, 1, 2, 3, so on. There. Doesn't matter what sort of graph I do, they may go up more, but they will always go through that point. The last two are fairly straightforward graphs that we have to know, and I'll just draw those on the calculator to make life easy. These two graphs are very simply the sine and the cosine graphs. So what I'm just going to do is draw these in for you. So I've got a graph of sine of x and I think I'm going to have to auto zoom this one, and there is the sine of x, and it starts off at 0, and the numbers down the bottom here would be more sensible if I could actually plot them in degrees for you. So for my sins, I'm going to try and draw this one for you. And bear in mind that I'm not very good at trying to draw these graphs. I'm going to have 0, this is going to be 1, that's going to be -1, because that's where it's going to go. Here is going to be 90 degrees, 180 degrees, 270 degrees, and 360 degrees. The graph starts at 0, rises up to 90, comes down to 180, back through 270, and up to 360 again. And that is the graph of sine x. In the same way, we have another graph, the graph of cos of x. And if I draw that on the same scale, in fact it's exactly the same shape of this graph, but it starts at a different place. So it starts at 1 and it comes down here and goes through 90 up to 180, through here at 270 and back at 360. So it's the same shape of graph, this and that one, it's just been moved along here a little bit. So there's our graph of sine and cos. I hope that's given you some idea of some of these curved graphs. We can do more of them, more about them. We can actually start working out turning points and other things, but that we'll do another time. Until then, if you found this useful, then please subscribe, give us a thumbs up, and I will see you next week when we'll do some more GCSE Maths topic by topic.